question which is about algebra and is worth 25 marks. In part A we have to solve this equation, giving our answers correct to 2 decimal places. Our first observation is that this is a quadratic equation, seeing as we have an x squared and an x term and then a term on its own. Since it's a quadratic equation, we can solve this with the classic minus b formula, which can be found on page 20 of your log tables. So here's the formula we're going to use, which gives us the value of x and contains 3 variables, a, b and c. In this case, a equals 1, b equals minus 4 and c equals minus 7. It might be worth learning this formula off, as it's used a lot in both junior cert and leaving cert algebra. So all we have to do is plug these values into the formula. So this is our new equation. Now we just need to multiply everything out. At this point you could just plug this equation into your calculator, but I suggest doing it out fully just for practice. Now that we've multiplied it out, this is as far as we can go without using our calculator. So all we have to do is put 2 plus or minus root 11 into our calculator and we'll get our 2 values of x. When we do this, we get x equals 5.32 or x equals minus 1.32, correct to 2 decimal places, and those are our values of x. In part B we're given another quadratic equation and 3 graphs a, b and c, and we have to work out which graph correctly depicts the quadratic equation we're given. We're also given 2 solutions for this equation in the question, which can help us match the graph to the function. Another word for these 2 solutions are roots of the equation. This is where the graph cuts the x-axis. So we know that the graph cuts the x-axis at x equals minus 1 and x equals 2. The function cuts the x-axis at these 2 points in graphs A and B, but not in graph C, so we can just forget about graph C. However, now we need to differentiate between graphs A and B. Another piece of information we can get about this function is where it cuts the y-axis. The graph will cut the y-axis when x is equal to 0. In this case, when we fill in 0 into our equation, we get minus 2. So the graph cuts the y-axis at the point 0, minus 2. Looking back at our graphs, we can see that graph A cuts the y-axis at minus 2, but graph B doesn't. So graph A must be the graph of our function. For our justification, we can say that graph A cuts the x-axis at x equals minus 1 and x equals 2, and it cuts the y-axis at y equals minus 2. And that's the end of our question. Thanks for watching this video, I hope it helped you, and I'll see you again.